Hello and welcome. This is Columbia Basin Research's sixth video in a multi-part series on using program user, which stands for User Specified Estimation Routine. User is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. Today we will look at program user's ability to perform hypothesis testing and model selection. Animals are captured and radio tagged at an initial tagging event. The study area is then surveyed at two subsequent sampling events, evenly spaced in time, and the number of marked individuals still alive are recorded. This is a known fate study, meaning that the detection probability is 1.0. If a marked individual is not detected, it is assumed to have died since the previous event. The model parameters are as follows. S1, the probability of survival from the initial tagging occasion to the first survey event, and S2, the conditional probability of survival from the first survey event to the second event, given survival to the first event. In addition to the survival estimates, we are also interested in knowing, number one, if the two survival probabilities are equal, number two, the overall survival probability for the study, S total equals S1 times S2, along with a confidence interval for the overall survival. The likelihood categories are as follows, and the data from the study are as follows. The full model has two separate period-specific survival probabilities, S1 and S2. A reduced model would assume a common survival probability, S1 equals S2. We can test if the full model better describes the data than the reduced model. Let's fire up program user. We define our parameters, as I'm doing right here. Click Next. In addition, we are interested in the overall survival, S total equals S1 times S2. Therefore, we need to double-click on the convenience functions to define S total as a convenience function like this. Then we must enter the likelihood definitions. The likelihood definition should match the previously mentioned data. After defining the likelihood, go to the Verify the Model page. Once everything has been entered correctly, go to the Parameter Seeds page. Since we are estimating probabilities, the default seeds of 0.5 should suffice. We define the convenience function S_total equals S1 times S2 because we are interested in a confidence interval for the overall survival. We'll be requesting profile likelihood confidence intervals, alpha level 0.05, for the individual survival probabilities as well as the overall survival. Advance to the Estimate the Model Parameters page and press Estimate. Now you can click on Estimation Summary. Here's the Estimation Summary report for the full model. In order to perform the hypothesis test, we need to record the log likelihood -5.63645. We are interested in comparing the full and reduced models. In the context of hypothesis testing, the null hypothesis is H0 is defined as S1 equals S2, the reduced model, versus HA is defined as S1 does not equal S2, full model. To define the reduced model, we can use the full model definition from the previous section as a starting point, as follows. Unlock the workspace so that the model may be changed. Go to Actions and select Clear Current Estimates. Press OK when asked for the confirmation. This will clear all estimates from the null model. Now double-click on Parameters on the navigation panel to return to the Parameters page. Right-click on the S2 cell and select Delete. We now have only one parameter, S1. Now go to the convenience function page and add the convenience function S2. Note that the actual likelihood definition does not need to be changed. The difference is that S2 is no longer a model parameter to be estimated, but is simply another name for the one model parameter S1. Go to the Estimate Model Parameters page and press Estimate. Click on the Estimation Summary. A new Estimation Summary report is created. As with the full model, we must note that the log likelihood is -15.2063. We can now test the hypothesis using a likelihood ratio test. The null hypothesis is S1 equals S2. The alternative hypothesis was S1 does not equal S2. The likelihood ratio test statistic is chi-squared equals 2 times -5.63645 minus -15.2063, which equals 19.1397. Chi-squared has an asymptotic distribution with 1 degree of freedom, giving a p-value of 0.00001, rejecting the null hypothesis in favor of the alternative hypothesis, S1 does not equal S2. The degrees of freedom for the chi-squared tests are always equal to the difference in the number of model parameters. In this case, the full model had 2 parameters and the reduced model had only one. An alternative approach to hypothesis testing is model selection based on an information theoretic approach, a la Burnham and Anderson 2002. With this approach, model selection is based on Akaike's information criterion, AIC. The model with the smaller AIC is the preferred model. In this example, the full model has an AIC of 15.2729, and the reduced model has an AIC of 32.4127. Based on the AIC, the full model is the preferred model. The full model is the preferred model because it has the lower AIC value. When selecting AIC, always choose the one with the smallest value. This has been lesson 6 on using Program User, in which we covered hypothesis testing. We hope that this video helps you get the most out of Program User. Again, if you have any questions or comments in regard to Program User, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your estimation routines, and thank you.